Okay, welcome back. So this lesson, I am going to show you a different method of solving quadratic equation, and we are actually going to use the square root. Okay, so last time we solved quadratic equations by factoring. Okay, today we are going to solve by taking the square root. Okay, so there are two warm-up questions for you to do, so I'll let you do that first. Okay, so hopefully these are the results that you got. Please make sure you got these answers right. These were what we did last time, so you just need to solve by factoring. Okay, so expand them, factor them at the end, make it equal to 0, make everything equal to 0, and then make each set of brackets equal to 0, and then those will be your solutions. For part B, you need to let a equals 2x minus 1. Remember that little trick that we did. So do that first, and then replace the 2x minus 1 back for a, and then you can solve for x after that. Okay, so that's the review. We are going to look at the so these two examples right here. So this again is solving quadratic equations by determining square roots. This does not always work. Okay, so this works when we have like this. We have an x squared term and just constants. We have no middle terms. Okay, because if we have this, we can actually again follow steps. First step, it says isolate the square term. In this case, we can actually move the 7 to the right and we get this. Okay, so plus 7 on both sides, you get 15. And then again, continue. We can isolate for the square term. We can divide both sides by 3. So 15 divided by 3 is 5. And now we can square root both sides. So when we square root this, we should get root 5. Now here it says, be careful, whenever you square root, you always get a positive and a negative answer, right? Because negative root 5 times negative root 5 is also positive 5. And obviously positive root 5 times positive root 5 will be positive 5. So you actually have two answers. And again, you can do it this way because you have the square term and constants. Or you could have this, right? I mean, this is the same thing. You have a square term, right? X plus 3 as one term squared, right? So square term and constant, like that. So in this case, we can right away square root both sides. You get x plus 3 is equal to the plus minus positive and negative square root of 20. Okay, now root 20 can be simplified, right? Root 20, recall, is, I'll show you the full steps just to as a reminder, I guess, because we've done this in the previous unit, and then we can say that we can take the square root of 4 out, so that's plus minus 2 root 5. And finally, to solve for x, we're going to move the 3 to the right, so then you get x equals negative 3 plus minus 2 root 5. Or you can write it as plus minus 2 root 5 minus 3. Okay, either or, it doesn't really matter. And there's your answer. Okay, two solutions. Okay, so again, this means your x, okay, let me just be clear in this case, it means x either equals to negative 3 plus 2 root 5, or it means that x is equal to negative 3 minus 2 root 5. So you actually have two answers, okay? So that's what that means, plus minus. You have two cases, either negative 3 plus 2 root 5 or negative 3 minus 2 root 5. Okay? So those are the two examples that I show you. Here are 3 practice questions for you to do. Good luck. Okay, so this first practice question, notice how at the end, because square root of 9 is a nice number, so at the end you get plus minus 3 minus 4. So in that case, you can actually evaluate these two numbers. Okay, so that's positive 3 minus 4, which is negative 1, and negative 3 minus 4, which is negative 7. Okay, so that's what you actually calculate in this case. Whereas in this, example right here, you would leave it like that because 2 root 5 is not a nice number. So just leave it like that. Okay, go ahead, continue. Okay, so again, something similar happened here. When you move 16 over, it becomes 36. And when you square root that, you actually get a nice number as positive or negative 6. And again, you can evaluate that because it's just a whole number, so it's easy to do. So once you move the negative 1 over, it becomes a plus. You can evaluate, you get 7 and negative 5. All right, last example or last practice question. Okay, so the last example or last practice question, move the 8 over, you get 2x squared equals to 48 divided by 2 on both sides, and square root, you get plus minus root 24. Simplify that, you get plus minus 2 root 6. Okay, so that's what you can do. Again, you do it this way if you have a square term and constants. Okay, you see, square term and 2 constants right here. Square term, 2 constant. Okay, so this is useful if you have that kind of situation. It's actually not too bad, right? All right, now, if you recall from last lesson, there was one question where we couldn't solve because it was not factorable. Okay, so we can actually solve that kind of questions or that kind of quadratic equations by completing the square. Okay, completing the square will solve any quadratics, in fact. Okay, so it could solve in the case where it's factorable, like this example here, or you could solve quadratic equations where it's not factorable. Okay, which are these 2 examples right here, which I'll show you in a second. But I'm gonna show you how it works first, and I'm gonna show you that it works even if it's factorable. Okay, so this method works for everything. It's a bit long though, okay, so just bear with me. So I'm gonna show you this one with just factoring, because this one's easy to factor. It's gonna be x minus 3 times x. Oh, wait a minute, is this even factorable? No, this is not factorable. Never mind, this one is not factorable. I thought this was factorable. I was wrong. Okay, I had it the other way around. That's right, okay, it's not factorable. Okay, so it's not factorable. Okay, never mind then. But we can still solve this by completing the square, okay? Now, I'm going to show you step by step, okay? What we need to do is... Okay, so here are the steps. I'm going to follow the steps, okay? It says arrange the equations so that the ax squared term and the bx squared term are on the same side. Okay, so we are going to put these two together, okay? So they're on the same side, okay? And then it says group the ax squared, whoops, there's an a missing here, and the bx terms. So we're going to group them together like what I just did there. It says divide out the leading coefficient from both terms in the group. Well, the leading coefficient here is 1. Okay, so we don't need to really divide anything here. And then here is the key right here, number 4. Step 4, it says add and subtract half of the coefficient of the x term squared. Okay, add and subtract half of the coefficient of the x term squared. Okay, I don't know if you understand that, but I'll show you. Okay, so what we're going to do is we're going to put x squared plus 4x. Okay, those are the same. And now what we're going to do is we're going to take the middle term, right? That's the x term. We're going to take half of that and then square. So half of 4 is 2, and then 2 squared is 4. So we're going to add 4 and minus 4. Okay, I'm going to put that in brackets, and we still have the minus 3 there, equal to 0. Okay, so that's step 4. Again, it says add and subtract half of the coefficient for the x term, right? Half of 4 is 2, and then square that. 2 times 2, or 2 squared is 4. So plus 4 and minus 4. Add and subtract, right? So plus 4, minus 4. So that's step 4. Step 5, it says remove the last term from the group. So we're going to remove this number outside of the brackets, okay? So because the leading coefficient here is 1, so when we remove it, we have to multiply this negative 4 with the leading coefficient. In this case, the leading coefficient again is 1, so negative 4 times 1 is negative 4. We still have the minus 3 there. Okay, so that's step 5. Number 6, it says factor the perfect square trinomial inside the brackets. So this is actually a perfect square trinomial, and that's why it's called completing the square, because this was not a perfect square. But once we did step 4 and step 5, this actually became a perfect square. This is actually x plus 2 squared, right? Because x squared is x squared. And then the middle term, you would have x times 2 and then 2 times x, which you get 2x and 2x. So you get 4x at the end. 2 times 2 is 4. Okay, so that is actually a perfect square. You still have the -4 minus 3 right here, so that becomes -7. Look at that. This is what we had in the previous page, right? We have a square term and a constant. Now we can solve this using the square root. Okay, so we are going to isolate for the square term first and then move 7 to the right. Now we can square root both sides. You get x plus 2 is equal to plus minus root 7. Finally, we can solve for x by moving the 2 to the right. So you get -2 plus minus root 7. And there is your final answer. Okay, you have two solutions, either -2 plus root 7 or -2 minus root 7. Okay, now you see this is how you can solve a quadratic equations that are not factorable. You can see, I mean, these numbers, you can't factor that, right? Because remember, if we were able to factor, the answer will be like fractions or whole numbers or integers. This is nothing like that. This is not a rational number, right? You have a root 7, so it's not a rational number. That's why you can't solve by factoring, because it's not factorable. But we can solve it by completing the square. Okay, I'll show you two more examples. This first one was easy because the leading coefficient was 1, so we kind of skipped the first 3 steps. Okay, now I'm going to show you how to do general quadratic equations, okay, where the leading coefficient is usually not 1. Okay, so here it says arrange the equations so the ax squared and bx terms are on the same side. Yes, they are already on the same side, so that's done. Group the first two terms, right, ax squared and bx term. Okay, so that's what I'm going to do. I'm going to say that, okay, I'm going to blow this up a little bit bigger because I'm going to need a lot of room to solve this equation actually. Okay, plus 2 equals 0. So I group them together. Number 3 says divide out the leading coefficient from those terms in the group. Okay, so in that bracket, so the leading coefficient here that we can factor out is -5 and plus 2x. Okay, we don't factor the x, okay, just the leading coefficient. Okay, and now we're gonna go to number 4. Again, step 4 is kind of confusing. What you do is you take the middle term, so the coefficient for x, divide that by 2 and then square. Okay, so if we take 2 divided by 2, we get 1. 1 squared is also 1. So we're going to add and subtract those two numbers. So plus 1 minus 1. And we still have the plus 2 at the end there. Okay. Now we are going to move this -1 outside of the bracket. Okay. So then when we take it out, we need to multiply by the leading coefficient right here. So -5 times -1 is +5. Okay, and now this is actually a perfect square trinomial. Okay, this is simply x plus 1 squared. Okay, if you notice, this number is always half of the original middle term, right? This is always half of the original middle term. You can see here, this was a 2. Again, the middle term was a 4, right? It's half of that. Okay, plus 5 plus 2, here we get plus 7 equal to 0. Now again, you see you got a square term and a bunch of constants. We can actually isolate for the square term by moving 7 to the right, which is -7. And now we need to divide it by -5, so over -5. Okay, so again, I move the 7 to the right, that gives me -7. And there was -5 times that, so to get rid of that, I need to divide it by -5. Okay, now I can square root both sides, plus minus. Now because both of these are negatives, so really it's just +7/5. Finally, we can move 1 to the right and you get -1 plus minus square root of 7/5, and that is the answer right there. Okay, so like I said, much longer process than the factoring method, but it's just that sometimes it's just not factorable. Okay, so unfortunately, that's what you need to do. Okay, again, I will show you one more time with the second example, and I'll let you try some. Okay. First step, arrange them so that they are on the same side. They are already on the same side. Number 2, step 2, we're going to group them together. So I'm going to say 1/2 x squared plus 3x inside the brackets minus 9 halves equals 0. Okay, divide out the leading coefficient. The leading coefficient here is 1/2. So factor that out. And remember, when we divide it by 1/2, when we factor, that means we're dividing everything by half. Divided by half means times 2, so you get 6x. Okay, step 4, again, add and subtract half of the coefficient of the x term. So we take half of 6, and that's a 3. And then we use 3 squared that 3. Okay, so 3 squared is 9. So this becomes plus 9 and then minus 9, right? Add and subtract half of that and square. So plus 9 minus 9. We still have the minus 9 over 2 here. We are going to move this negative 9, okay, the last term, outside of the bracket. So we need to multiply that by the leading coefficient outside, which is 1/2. So 1/2 times negative 9 is negative 9 out of 2. Okay, now this is a perfect square trinomial. And again, like I mentioned earlier, it's just going to be, this number is always half of the 6 right here, you can see. Okay, so squared. Negative 9 over 2 minus 9 over 2 is negative 18 over 2. And, well, 18 over 2 is 9, so I'm just going to write it as minus 9 right here. Okay, now again, we have a square term and constant and the leading coefficient there. We can actually just multiply or move them to the right. So again, the first step to move it to the right is moving the 9 to the right. That gives us a 9. We need to divide it by half to get rid of that. But remember, divided by half is like times by 2. So there you go, times 2, so 18. Now we can square root both sides. So x plus 3 is equal to plus minus 9 times 2. I'm actually going to write it as 9 times 2 because we can actually simplify this, right? Square root of 9, we know that's a 3. So last step, I'm going to move the 3 to the right. That becomes negative 3 plus minus, again, 9. Square root of 9 is just 3. And there's the root 2 there that we cannot do anything about. So there's our final answer. Okay, how many steps? 1, 2, 3, 4, 5, 6, 7, 8 lines. Okay. Again, you just need to practice. Really, it's all about practice. Once you do enough, completing square is not that bad. It's a long procedure, but once you do a few, it just becomes second nature. Hopefully. For me, it's a second nature already, right? So you just need to practice. And therefore, there are 2 questions for you to do. Okay, good luck. All right, I will walk you through because this is something new, more challenging. Okay, so first, I'm going to group them together. They are actually kind of already grouped because 2 is on the right hand side. Okay, I need to factor the leading coefficient. Well, there is none, it's just 1, so that's it. But what I need to do right now is I'm going to take half of 4 and then square that. So that becomes a positive 4 and negative 4 equals to 2. Okay, again, the leading coefficient here is 1, so really you don't need to put them in brackets. If you did, that's fine. That's perfectly okay. Now, the first 3 terms would be a perfect square. That is just x plus 2 squared. We still have the minus 4 there. Okay, now I can move the minus 4 to the right because this is just a square term with a constant, or with 2 constants, I guess. Move it to the right, I got a 6. Now I can square root both sides. I get plus minus root 6. Finally, move the 2 to the right, you get negative 2 plus minus root 6. Okay, that's the answer for part A, or for the first practice question. Hopefully you got that right. Okay. Part 2, or second question here, this we do need to put these first 2 terms in a group. Okay, like that. Okay. Now we can factor out the leading coefficient, negative 2. And you get negative 8x. We factor out negative 2. And now we can take half of the middle term, which is going to be 4. And then square that, so it's going to be 16. So plus 16 minus 16 minus 3 outside of the bracket equal to 0. Okay, we are going to move the negative 16 outside. So this is going to be, oops, squared. Remember, when we take it outside, you got to multiply by the leading coefficient right here in the front. So negative 2 times negative 16 is positive 32. So plus 32 minus 3. Now we know this is going to be a perfect squared. This is simply x minus 4 squared. Again, this 4 is always half of that. 32 minus 3 is 29. Now we have a square term and a bunch of just numbers, so we can actually isolate for the x minus 4 squared term. First, move the 29 to the right by subtracting 29, so 0 minus 29 is negative 29, and then divide it by negative 2. Okay, and now I can square root both sides. Again, both of these are negative, so when we square root, we can just write the positive ones. And then finally, move the 4 to the right. That is a positive 4, so it's plus minus square root of 29 over 2, and that is your final answer. Okay, so slightly longer than the first practice question, but again, it's not like it's not doable, okay? It's actually quite doable. It's just long procedures. Okay, last example I'm going to show you for this lesson. Here is the word problem. It says when the square of a number is added to the number, the sum is 3. Okay, when the square of a number, so this number is the unknown. So let number be x, because that's the unknown, right? So the square of a number, so that means x squared, is added plus to the number itself, so plus x. The sum is 3. Okay, what's the number? Okay, now we just need to solve for x now. Okay, now you can see this is not factorable even if you move 3 to the right, to the left. Okay, I kind of need some room here. I need to write smaller. Okay, x squared plus x equals 3. Even if you move 3 to the left, this is still not factorable. Okay, so now what we need to do is completing the square. Okay, so I'm going to put these two in brackets. Okay, and now there's nothing for me to factor out, so I'm going to expand again by taking half of the coefficient in front of x, which is 1, and half of 1 is 1/2, and square of 1/2 is 1/4. So it's going to be plus 1/4 minus 1/4 equal to minus 3 equal to 0. Okay, now let me say it again. That's a plus 1x right here. So to find these two numbers, what we do is we take half of 1, which is 1/2, okay, and we take that 1/2, square that. So square 1/2 is 1/4, and that's how I got plus 1/2 and minus 1/2. Oh, sorry, plus 1/4 minus 1/4. Now we're going to move this negative 1 over 4 out, but because again the leading coefficient right in the front is just 1, so really you can just kind of move it out because there's nothing for us to multiply. Now because that's a minus 1/4, so I know I need to combine fractions. I might as well turn 3 into 12 over 4. Okay, now I can factor this. Again, this is a perfect square. That is simply x plus 1/2 squared. Again, this is always half of the coefficient right here. Now if I combine these two terms here, I get negative 13 over 4 equal to 0. Now again, I can isolate for this square term. So x plus 1/2 squared is equal to 13 over 4 if we move the negative 13 over 4 to the right. Now I can square root both sides. So x plus 1/2 is equal to plus minus square root of 13 over 4. Okay, finally, we can move the 1/2 to the right. That becomes negative 1/2. Plus minus. Okay, now remember it's a square root of a fraction. We can actually split them, and this time it's useful to split them because we can actually get square root of 4, and that's just a 2. So there's our final answer, square root of 13 over 2. Okay, so again, root 13, nothing we can do, but we can do something with root 4, so that's why I split them. Okay, and that's your final answer. The number is either negative 1/2 plus root 13 over 2 or negative 1/2 minus root 13 over 2. So you actually have two answers. All right. That's it. Okay. You know what? Actually, we should probably check. I don't know if both of them actually work. One of them might not work, you know. So I'm actually gonna plug into calculator and see what happens. Let me just make sure, okay? I know I don't want to make myself look like a fool when it doesn't work. So let me just plug into calculator and double check. Okay, so I'm using the positive one. Okay, I'm gonna pause the recording. Okay, so it turns out that both do work. Both of them will work, so then we are fine. Okay, so you should always check by plugging these numbers into your original equation right here and see if it works. Okay, so that's the lesson for today. Again, try some questions in the book. Let me know if you need help. Good luck.